Today we're delving into Unit 2.3 of the first half of General Chemistry, which goes over atomic weights. Atoms are technically small bits of matter, so therefore they have mass. However, atoms of different elements do not always weigh the same. For example, 10 grams of water with its chemical formula H2O has 1.1 grams of hydrogen and 8.9 grams of oxygen, even though there are twice as many hydrogen atoms, H2, compared to oxygen atoms. Therefore, an atom of oxygen weighs approximately 16 times more than a hydrogen atom, which is the lightest element. Being that it is the lightest element, hydrogen was given the relative mass of 1 with no units arbitrarily, and all other elements' masses were calculated from it. Another way to calculate the mass of atoms is through the use of atomic mass units previously discussed in Unit 2.2. Remember also from Unit 2.2 the term isotope, which were atoms with the same number of protons, but different number of neutrons. These isotopes vary in abundance, meaning that some isotopes are rarer than others. For example, with carbon, 98.93% has 6 neutrons, which we call carbon-12, and 1.0% has 7 neutrons, which we call carbon-13. To determine carbon's atomic weight, we just multiply the masses by the percentages to get the average mass. This looks like 0.9893 times 12 AMUs plus 0.01007 times 13.00335 AMUs to equal 12.01 AMUs. Note that carbon-13's mass equals carbon's 12 mass plus the mass of a neutron. Based on what you learned, think about the following question. Explain how the atomic weight of 79.904 AMUs of bromine is calculated. Thank you so much for spending your valuable time learning and bettering yourself. If you like the video and want to learn more, donate, or get tutoring, please check out my website, nocollegeneeded.org. You can use the code NCN for 20% off tutoring and any supplemental materials. If the subject isn't up yet, please be patient. I'm working on bringing them up as soon as I can.